we have a diagram right here, which is good. And we have two lines, AB and CD, they intersect at E. And what I'm thinking off the bat in my brain is using coordinates. And what do I mean by this? So, using coordinates, we can graph out. First, we can find the equations of the two lines and find um, the the point of where E lies. And that will help us in solving and finding segment AE. So let's start in the bottom left corner. Okay, the bottom left corner we're going to set as the origin or 0, 0. And we can find that D is 2, 0, B is 6, 0, and A is 0, 3, and C is 2, 2. So let's first find the harder equation for the line AB. Okay, so the equation of the line AB, we first have to find the slope, rise over 1, y2 minus y1 over x2 minus x1. And when we do that, we find that the slope is negative 1/2 x. And if you want me to go over an in-depth algebra video about slopes, please leave a comment down below if you want to see that. Okay, so y is equal to negative 1/2 x, and then we find the y-intercept, and it's 3. So yeah, there's multiple ways to find equations of lines. It's not the only way. There's point slope form, slope intercept form as I'm using, and multiple different ways that you can find the equation of lines. But it will be really useful. So AB, the line of AB is actually I'm not gonna do equal sign. Is y is equal to negative 1/2 x plus 3. And now we're gonna find the line of CD. So the segment of CD right here, and we can do the same thing. We first find the slope, and the slope is 1, and we find the x-intercept, which is negative 2. My bad, negative 2. Okay, so the x-intercept is negative 2. No, y-intercept is negative 2. Sorry, because you can plug it in as well. So we have the equations of the two lines, and this intersect at E. So that means they have, at that point E, they have the same x and y coordinate. So we can set the these two equations as equal. So y in this case is equal to negative 1/2 x plus 3. So we'll write that. And since y's are both the y's in this both of these equations are the same for that point, we set them as equal. And y in this case is also x minus 2. So it's also x minus 2. And then we solve, move the x's to one side, the constants to the other, and we find that x is equal to, I don't know why my pen stopped working. There you go. Yeah, my pen's not working today. Oh, there we go. 10 over 3. Okay, so x is equal to 10 over 3. We substitute back in, and we find that y is equal to, I think it's, we substitute back in. This equation seems much simpler, and y is equal to 4 over 3. Okay, so we just basically already found the coordinate for E. The coordinate for E, in our case, is 10 over 3. And for its x coordinate, and 4 over 3 for its y coordinate. So we're going to write E. The coordinate E is this, 10 over 3 and 4 over 3. And you're like, Daedalus math, how is this going to help us? Well, it helps us. It helps us in finding AE, because we can either use the distance formula, because we already found one coordinate and we have the coordinate of A right here, or we can use a right triangle. So if you didn't memorize the uh, distance formula, which we're trying to find because the length, obviously, and we can use a right triangle and the Pythagorean theorem. So E is 10 over 3, and from its, we'll call this, let's say, F, this point F. So the point F has a x coordinate of 0, and the point E on the same line has an x coordinate of 10 over 3. So we know that FE is 10 over 3. And FA, what is FA? Well, we have to be careful here. F all the way to 0, 0 is 4 over 3. And the reason why is because that's the y coordinate up to E, as you see here. And then we can check out the uh, y coordinate for A, and it's 3. And then we just subtract, and we find that AF is 5 over 3. So 5 over 3, 10 over 3. We can use a squared plus b squared is equal to c squared, and we find out that the answer choice is B.